Hello students, how are you? Wherever you are, this is Eros Anglican Grammar School online teaching. I want you to get your pen, your biro, your calculator as we go on our teaching today. And I want to use this opportunity to thank our amiable principal, Reverend Kanosakwe Dokolo, who worked tooth and nail to ensure that this online teaching is a success. Wherever you are, if you have your cell phone off them, I need your 100% concentration. Now today we have a topic before us, variation. Now before we go further, you have to know the meaning of variation. As you all know, variation is the relationship that exists between two or more quantities in which a change in one quantity leads to a change in the other. That is, when we talk about variation, when we have two or more quantities, how they relate, how the effect of one affects the other. Now we go to types of variation. We have four types of variation, which are, we have the direct variation, the inverse variation or indirect variation, the joint variation, and the partial variation. We are going to study them one after the other. We are starting with the direct variation. In direct variation, if one quantity is increased or decreased, the other quantities is also increased or decreased in the same rate. For example, when we talk about like work and energy, if you have high, that's an example of direct variation. If you have a high energy to work, so your work will also increase. So let's start with example 1 of the direct variation. If n varies directly as n and n equals to 15, where n equals to 8, find the equation connecting n and n, and hence find n when n is 25. I repeat the question again. If n varies directly as n and n equals to 15, when n is 8, find the equation connecting n and n, and hence find n when n is what? 15. So get your biro, get your paper once again. Let's solve it together. Solution. Now, to solve this, look at the question. N varies directly as n. That is, n varies directly as n. This sign, we call it variation sign or proportionality sign. Okay, so this is an example of direct variation. N varies directly as n. Now, when we write n varies directly as n, the first step is to remove this variation sign and put equal to. When we put equal to here, we multiply the quantity in this side with a constant, which is normally k. You say kn, kn means k times n. Then you say where k is a constant. Where k is a constant. So we substitute the value of those variables now. When n is 15, n is 8. So n is 15, you put 15 here. You know that this one means k times n. That means k times n. N is 8. So we have 15 equals to k times 8. We have 8k, not k8. Students, can you get that? We have 8k. Now the next thing, to get the value of our k, we have to divide both sides of the equation. Now to get the value of k now, we divide both sides by 8. Now students often, they made this mistake. So we just divide both sides by 15. No, whether the unknown is left hand side or right hand side, we divide both sides by what is by the unknown, the coefficient of the unknown, whether it's in left hand side or right side. This is k. What is by k is 8. So divide both sides by 8. You now have 15 over 8 equal to 8k over 8. 8 cancel 8. Then 15 divided by 8, if you have your calculator there, you can leave it that way. 15 over 8. Or rather, that will give us one whole number, remainder 7 over 8. Now the question now says find the equation connecting n and n. Now to get the equation connecting n and n, sometimes they may put it this way: what is the formula connecting n and n? Or what is the relationship that exists between m and n? What you do now, once you get your constants, substitute for your constant in your real equation. This is your real equation now. This very one is your real equation of the variation. So we put it back: n equals to kn. Now, to the equation connecting m and n now is to substitute for the value of our constant, which is k. So we have m equals to 15 over 8n. So this is the equation connecting m and n. That's the answer. Then the question goes further, say hence find n when n is 25. Find n when m is 25. That is, you write your equation again, which is m equals to kn. You say find n when m is 25. You write 25 here, m is 25 now, equals to k, which is 15 over 8 times n. That will give us 25 equals to, you know, this is the same thing as over 1. 15 times n, that will give us 15n. Over what? Over 8 times 1, we have 8. This is the same thing as over 1. You cross multiply. By the time you cross multiply, always do the unknown first. 15n times 1, that will give us 15n. 25 times 8, that will give us 200. Is that taking, students? So that will give us 200. So what we do here is we divide both sides by 15. You know, this is by 15. This is the unknown. This is the coefficient. Always divide both sides by the coefficient of the unknown. We now have 200 over 15. That will give us 15, cancel 15. Our n, if you want to, you can say 5 here. That will give us what? 4. Okay? That's 40. Okay, 5 here, 3. We now have 40 over 3. You can decide to put it in improper mixed fraction. It can be mixed fraction. Okay, that will give us 30 whole number, remainder 1 over 3. Or rather, you can say your n, if you want to put it in decimal, your n can be 13.33. Sometimes there's what we call premature approximation. Some students will just say 13.3. No, if you use 13.3, by the time you use this value to solve other questions, it might affect your solution. So that will give us 13.33. So this is the value of n. Sometimes they may put it in sentence form, sometimes they may put it, they will translate it for you. This is translated already. It reads, if y varies directly at the square root of h. If y varies directly at the square root of h and h equals to 16 when y equals to 9. The question now is find Roman figure 1. The relationship the relationship between, or that exists between y and h. Roman figure 2, the value of y when h equals to 36, and lastly Roman figure 3, the value of h when y equals to 27. Students, are you there? So look at our question again. I repeat the question. I said sometimes they may put this question in sentence form from you, translate it into variation symbol. But sometimes it will be translated for you, like this one is already translated. It reads, if y varies directly at the square root of h, and h equals to 16 when y equals to 9. Find Roman figure 1, the relationship between y and h. The value of y when h equals to 36. Then Roman figure 3, the value of h when y equals to 27. Let's quickly solve this. Solution. Now, y varies directly at the square root of h. As I said earlier, this is the variation sign or sign of proportionality. Now, to remove this sign, we put equal to. Immediately you put equal to here, you multiply whatever you have in this quantity, in this sign, with a constant, which is k. K square root h means k times this. Now we want to substitute the value now. You say when h equals to 16, y was 9. So I put 9 here, I'm substituting now. So what I do here, I'm now saying k times h was 16. You all know that equals to the square root of 16. Square root of 16 is 4. 9 equals to k times 4, that will give us 4k. Now you can see now, we divide this, the unknown now, which is k. Divide both sides by 4. Now have 9 over 4 equal to 4k over 4. Students, are you following? Now 4 cancel 4. And now have 9 over 4 equals to k, which is the same thing as k equals to 9 over 4. If you want to change it to mixed fraction, you can say k equals to 2 whole number, remainder 1 over 4. It's the same thing. Now, in this question, we will not ask the value of the constant. Okay? But the constant, they will still mark it for you. This is your constant now, 9 over 4, which is the same thing as 2 whole number, 1 over 4. Let's go to Roman figure 1 now. You see the relationship between y and h. That's Roman figure 1. When we talk about the relationship between y and h, it's still the same thing. Now, what is the formula that connects y and h? Okay? Or find the value, the relationship between y and h, or the relationship that exists between y and h. It's still the same thing. What you do here is this: you substitute for your constant in your real equation now. This is your real equation now, the one you multiply with a constant k. Mind you, you must write where k is a constant, because if y is marking this, for example, y we put question mark here for you, because here we ask, the examiner will ask you, you didn't define the value of k. Sometimes we deduct mark for that. You didn't define k for you because the quantity they gave you was y and h. So you have to tell the examiner the meaning of your k. But some students do often ask, must we use k? But for the purpose of direct and inverse variation and joint variation, it is advisable that students use k as their constant. In partial variation, you can use other variable as constant. Is that clear, students? Now let's proceed. Now, Roman figure 1, the relationship that exists between the two variables is you picking your normal equation equals to k square root of h. So the relationship that exists between them is to substitute for your what? For your constant, which is 9 over 4. It will now be y equals to 9 over 4 square root h or root h. So that is the answer for Roman figure 1. Let's go to Roman figure 2 now. Roman figure 2. In Roman figure 2, we will ask, find the value of y when h is 36. You put down your Roman figure 2, you put down your normal equation, which is a square root of h. You say find the value of y when h is 36. So your y, you know that this one means k times square root of h. Are you there, students? So your y will now be your k, which is 9 over 4 times square root of h. Where h is what? 36. You put 36 here. Are you there? So what we do here is y equals to 9 over 4 times square root of 36, which is 6. Okay, this is the same thing as over 1. 2 here 2, 2 here 3. Are you there? So we say y 9 times 3, which is 27. 27 over what? 2. You can leave it like this in improper fraction, or you can say y equals to 13. You can also leave it in decimal, 13.5, or you can say 13 and a half. This is the value of y when h was 36. Then lastly, for this example 2, Roman figure 2, you write your real equation again, k square root h or root h. See, the value of h where y is 27. So the value of h when y is 27, let's substitute again. 27, y is 27. You know that this one means k times this. So our k is 9 over 4 times square root of h. We don't know h now, we are looking for h. Are you there, students? So let's go. 27 equals to, this is the same thing as over 1. 9 times this in salt, for example, we say root. We normally, if this one means root h. If you don't want to say square root of h, you call it root h. Now 9 times this, that will give you 9 root h. 4 times 1, we have 4. You can call this over 1 is the same thing. The next thing is to cross multiply. When you cross multiply, okay, always do the unknown first. 9 root h times 1, that will give us 9 root h, equals to 27 times 4, I think that will give us 108. Students, are you there? So what we do here is that this is the unknown, this is the coefficient of this unknown now. We divide both sides by 9. So 9 root h over 9 equals to 108 over 9. Are you there, students? So what we do here now, we divide both sides by 9. 9 cancel 9. Here, then here is 12. So our root h is equals to 12. Then the question is not root h. We are looking for h. So we have to drive this square root away. Now to drive that square root away, student, some students normally find it difficult. Some will say square both sides. No. Look at it. For example, look at this. If I have a square, for example, equals to 12. Now I'm looking for h. To drive this my h away, I will square root. I will square root both sides. This one will cancel this. That's to drive. But if I have a square root, to drive square root away, you take the square of both sides. Are you there, students? So we are squaring both sides now. We now have h square equals to what? 12 square. This one will cancel this. So our h will now be, this one means 12 times 12. Our h will now be 144. Okay? I know some students will ask me now, how did these two cancel this? Now, in indices, if I say this, for example, it means h raised to power 1 over 2. Students, are you there with me? Now, this one means h raised, any square root means h raised to power 1 over 2. So, raised to power these 2. There is a law in indices we call product of indices. When power raised to another power, you multiply the power. So 1 over 2 times to this, we cancel this. So remaining h. H raised to power 1 is what? Is h. So you can see that's how we have h here now. So in conclusion, our h is 144. Is that clear, student? Let's go to the last example for the direct variation before we do some exercise at home. The last for direct variation, the one we have with us here is example 3. Students, are you following? Example 3. In example 3, it said y varies directly as an unknown power of x. Okay, example 3, this past y question. You have to take note of this past y question. Okay, see y varies directly as an unknown power, of x. Full stop. See, express y as a function. Express y as a function of x. Express y as a function of x. Given that, given that when s equals to 2, y equals to 0.4, and when s equals to 4, y equals to 6.4. In this question, they gave us a guideline. They say take the unknown power of x to be n. To be what? To be n. Sometimes they may not give you this guideline. All you need to do, the variable we are giving is x and y. So you, on your own, pick any power aside n. In case you see a similar example like this, that they didn't give you a guideline, but here they gave us a guide. Take the unknown power of x to be n. Students, are you following? So in a situation where they didn't give you a guideline like this, you can pick any variable of your own aside x and y. But if you still want to use x or y, you have to differentiate. For example, this is, I can decide that let the power be s prime or let the power be y prime. It should not just be the normal y they gave you. Is that clear? So let's solve this question now before we do our exercise. Okay, the question once again, let's translate it now. This one is given in sentence form. Take note, it's past y question. Y varies directly as an unknown power of x. Solution. Y varies directly as an unknown power of x. They said the power of x should be what? Should be n. So let's put n there. Are you seeing it now? We have translated. Now what we do here is this. By the time you remove this variation sign or sign of proportionality, you multiply the quantity you have this way with k, which is k times s raised to power n, and that will give us k s raised to power n. You must tell the examiner where k, what is your k, where k is a constant, where k is a constant. Now we want to substitute what we have now. Now in the first place they say when s is 2, y is 0.4. Y is 0.4. When s is 2, I substitute 0.4 equals to k times 2 raised to power n. And that will give us 0.4 equals to k 2 raised to power n. We call this one equation 1 because of what we have there. Now, another one was given when s is 4, y is 6.4. So, this is our re-equation now, the one we are using now. So, when s is 4, y is 6.4. I substitute for y 6.4 equal to s is 2. So, I will now say k times 2 raised to power n. K times 2 raised to power n. And that will give us 6.4 equals to k 2 raised to power n. We call this one equation when s is 4. Okay? Sorry, s is 4 here. S is 4. S is 4. 4 raised to power n. So k 4 raised to power n, I call here equation 2. Are you there now, student? So let's proceed. So what we have here now is, let's rewrite the equation again. 0.4 equals to k 2 raised to power n, equation 1. 6.4 equals to k 2 raised to power n, 4 raised to power n, equation 2. Now, we are not going to use the unknown to determine the equation that is bigger. Let's take the constant now for you to know which equation to divide the other. Now, here we have 0.4. Here we have 6.4. You know that the lesser one divides the greater one. 6.4 is greater than 0.4, right, students? So what we do, we say divide equation 2 by equation 1. Say divide equation 2 by equation 1. So equation 2 is 6.4 divided by 0.4 equal to k times 2 raised to power n. K raised to power n is the same thing as k times divided by k times 4 raised to power n over equation 1, which is k times 2 raised to power n. Are you following, students? You can see that k has cancelled k. Are you there? Now, 6.4, if you have your calculator there, 6.4 divided by 0.4. You can use your calculator to do that now very fast. You can use your calculator to do that very fast. 6.4 divided by 0.4, you have 16. Now look up now. This one now means 4 raised to power n divided by 2 raised to power n. I know some students will say 2 here 1, 2 here 2. No, you can't do that. As far as there is power here, it's a mathematical error for you to divide. Say 2 here 1, 2 because of the power. So what do we do here? We are going to apply some law of indices here. You can see one topic leads to another. There's no topic that doesn't relate in mathematics. We are going to use indices now to break this thing down. You know this 4 is the same thing as 2 raised to power 2. That is my 4 raised to power n over 2 raised to power n. Students, are you following? Now what happened here is there's what we call, there's a law in indices, product of indices. When power raised to another power, you multiply. So we are going to multiply those two powers now. 2 times n will give us 2n over 2 raised to power n. You cannot still divide this 2 here, 2 here. No, you say there is 2 here. No, because of this power. If you do that, you are wrong. Now, students, what we do here is 16 equals to, now I want to simplify this for us now for you to understand, students. Look at it. This one, I can rewrite it as 2 raised to power 2n. You see this one now, divide by 2 raised to power n. Is that clear? For clarity. Now, when we have this now, 16 equals to, now there is a law in indices as well, that when you have the same base and its division, you minus the power. So 2 here, this is the base, 2 here, this is the base. So what I do, and there is division. Assuming here was multiplication, I will add the power. The power here is 2 raised to power is 2n. The power here is n. So I will say 2n minus n. And I have 16 equals to 2. 2n minus n. Some students, I know you tell me the answer is n. No. Is 2. No. You say 2n cancel n. No. 2n minus n. This n means 1n. If the coefficient of a variable is 1, there's no need of writing the 1. This one is the same thing as 1n. So 2n minus 1n, which is n, is n. Are you seeing it now? Now, what do? We are going to apply the knowledge of exponential equation here, or indicial equation. Now, this 16, another way of writing 16 is 2 raised to power what? 4, equal to 2 raised to power n. Now, in indicial equation, the rule is that if you have the same base on both sides, they cancel out. The one we call either base cancel base or power cancel power. Now, if you check this equation, now the base on both sides are the same, they cancel out. So I will say 4 equals to n, which is the same thing as n equals to what? Equals to 4. In our equation, in our question, they say find the function. We were asked to find the function. Express y as a function of x, given that this. So our concern here is to express y as a function of what? Of x. So what we do here is that, now we have gotten for n now. You know, this is 2 equations now. In 2 equations, once you got one variable, you must get the other one. So you can take either equation 1 or equation 2, the one that will be convenient for you to solve. Now let's use equation 1 now. To find k, look at the 2 equations we have. To find k, substitute. The word substitute here, it means to replace. Substitute for n equals to 4 in equation what? Equation 1. Let's pick equation 1 now. What's equation 1? Look at equation 1. 0.4 equals to k. I can say it's the same thing as k times 2 raised to power n. Are you seeing it? 0.4 equals to k 2 raised to power n means k times 2 raised to power n. So 0.4 equals to, we already know k. We already know n. N is 4. So k times 2, you see this n now, which is 4, 2 raised to power 4. We know that 0.4 equals to k times 2 raised to power 4 means what? 16. 2 times 2 times 2 times 2. So that will give me k times 16. That will give me 16k. Students, are you following? So let's proceed now. That's 16. So this is the unknown, which is k. So we are looking for what now? Our k. What is the coefficient of k, which is 16? We divide both sides by 16, not 0.4. So 0.4 over 16 equals to 16k over 16. 16 cancels 16. So 0.4 over 16, that will give us k, or rather 0.025 equals to what? Equals to k. And k is the same thing as 0.025. We can as well write it in fraction. Okay? So 0.025 is the same thing as what? 1 over what? 40. Is the same thing as 1 over 40. So in our question, they say the relationship, the function between y and x. So you write your real equation again. Our real equation, hence, Your real equation, which is y equals to k s raised to power what? N. Are you there now? So we want to substitute now for our k and x. So look at your real equation now. Your y equals to our k here is what? 1 over 40 x. Our n was what? Our n was 4. So we put your 4 here. So this is our final answer. Is that clear? Students, I will advise you when you are solving mathematics is step by step. I know some students will just maybe just jump, look for somewhere to write and just no. You have to, every step in mathematics has a mark. You might not arrive here, at the end of the day, you may still come out with a good grade. So always go for step by step. Is that clear, students? So let me give you some exercise to do now while you are there watching. Okay, students, we have some exercises before us which you are going to do right away now, and you are going to submit. You are going to submit to our portal 2. Number 1, question 1. N varies directly as the square root of p. And n equals to 15 when p equals to 36. Find Roman figure 1, the formula connecting n and p. Roman figure 2, n when p equals to 121. The Roman figure 3, p when n equals to 49. Question 2. If x plus 3 varies directly as y and s equals to 3, when y equals to 12, what is the value of x when y equals to 8? This is another example of y question. Okay, it's a past question. The last one, question 3. The distance covered by a car is directly proportional to the time taken. If a car travels a distance of 200 km in 2.5 hours, find Roman figure 1, the distance the car will cover in 8 hours. Roman figure 2, the time taken for the car to cover 500 km. In our next class, we are going to go to other area of variation, which is inverse variation, joint variation, and partial variation. So do this assignment and submit it. Thank you. My WhatsApp number is 081 81 950 949. I repeat, 081 81 950 949. I want you to submit this so that in our next class we can go for other branches of variation. Thank you very much. God bless you.